Okay, so in this series of videos I've been looking at Python programming with a focus on efficiency. So this is looking to address this section of the Component 1 controlled assessment practical project syllabus, so how to provide annotated evidence showing that a solution has been coded efficiently. So for this last video I'm going to have a look at this one, so considering the use of alternate data structures. So I'm going to look back over the first example program that I used in this series. This was the error code checking program. So this, you can see there's quite a lot of repetition here. I'm using what would be kind of referred to as a case statement in other programming languages, so a series of ifs and ELIF statements where the program is looking to match the user's input to something it has stored in the program and then deciding the action to take based on that. So we're going to have a look at using an alternative data structure to represent the solution to this problem, or to help with the solution to this problem. So what you're probably aware of at the moment is that we don't have to store single items of data in each variable. We can put things in a list. So for example, something like names we represent like this. So rather than having three variables, name1, name2, name3, I can make a list of three names, and then what I can do is I can refer to the first name like this, or the second name like this. So in Python, indices begin at 0. You need to remember that when you're doing your exam, in the algorithms that they show, indices begin at 1. So I'm going to show you another data structure now, and this is something called a dictionary. So rather than the dictionary, a dictionary's values being referred to by numbers, so indexes, the way a dictionary works, if I have a dictionary called names, and for example there was a new name in the dictionary, I could refer to the new name by using this key. So the way that a dictionary works is that it's made up of what are called key value pairs. Okay, so the value is the item of data, and the key is another bit of data that you're going to use to refer to the value. So you can see how I can implement that in this solution. So I'm going to do a few find and replaces just to change the program. So I'm going to look for every time I've got print like that, and I'm going to replace it. I'm now going to have a look at removing some of this, and hopefully what we're going to see is once I've finished coding this solution, we're going to see that it's even more efficient than the fix we applied before. Whoops. Okay, so now what I'm going to do is I'm going to delete these closing brackets. So it makes sense to use a data structure like this. If you have a large set of data and the program is going to be required to look up values, then it makes sense to kind of collect all that data in a structure. So I need to separate each item of data that I'm making, so I'm going to put a comma. So just like when we represent a list, it's going to be the same thing in a dictionary. Each key value pair is separated with the comma. Okay, so now I no longer need this if error is equal to, so again I can find and replace, sorry, ELIF error is equal to, so I can find and replace and remove it all. And we're getting closer. I actually just removed one too many things then, so I'm just going to put, need my quotes in, because what I'm forming now is a dictionary, and each key is represented as a string. Just like the value is also going to be a string, the key is going to be represented as a string. So here is where the different syntax is going to come in. So I know now that with a list I use these square brackets. A dictionary actually uses the curly braces. So I'm actually going to call my dictionary error lookup. So I'm giving it a variable name and I'm assigning it to the dictionary. I need to close with the curly brace as well. And just to make this a little bit more readable, I am going to go through and indent this so they're all in line. So what I'm actually going to do is copy my tabs and just go through quickly and paste this. And we're doing two things here. So we're also improving the effectiveness of the programming by hopefully making the program run quicker. But as you can see, this actually makes the code more readable. So back to what I said at the original video in this series. So another way to kind of improve efficiency is to make your code more maintainable. So this can be when you come back to the code, so it helps you to update it if necessary, and also when others look at your code. Alright, so the way this works is now the error code is going to be still input by the user and stored in this variable, but now the key value pairs are stored inside my dictionary. And remember what I said, so the syntax for a dictionary are these curly braces. So now in order to get the error code, what I would say is print, and then I'm looking in error lookup, and it's the same syntax as when you're using a list, but inside here I'm going to put the key, and my key, because the user entered it, is now going to be stored inside error, like this. So hopefully when I run this program now, using the same test data as the first video, so I'm going to look for EU, we're going to see that this executes quicker. Okay, so I'm going to run my program, type in EU, and what we can see that this is now reduced significantly. So from the first video when it was 0.8 in the solution using ELIF, we've now got that down to 0.2. So what this is showing us is that if we can organise code in slightly more complicated data structures, but not only does this improve the efficiency of the program when it runs, but it's also quite a lot nicer to look at, easier to read, therefore easier to maintain.